the equation of a line that you will encounter, that you will see, that you will be expected to use. But the two that we're going to work with the most often are y equals mx plus b and y minus y1 equals m times x minus x1. There is this third that looks like what I'm already messing it up because I don't use it that often. Don't think I can save that. We're going to have to erase it. Ax plus by equals c. So these are our three versions for the equation of a line. The first two are the ones that we're going to work with the most often. And this is the really helpful form if what I know is the slope and the y-intercept. This version is a better form if I know the slope and 1 point. So let's say that I told you that we're going to write the equation of a line with a slope of 2/3 and y-intercept 0,7. It is not very common that this is the way information would be presented to us, but it's the easiest form that the information can be in and be able to write the equation of a line. So actually, I lied. This is often how the information is presented to us in a statistics setting. So good times. In terms of, I have a slope and a y-intercept, so I'm going to use this slope-intercept form. That slope is the value of m. And that y-intercept I have listed as an ordered pair, meaning the x value should be 0 for any y-intercept, and the y value here is 7. In terms of that slope-intercept form for the equation of the line, that y-intercept value is b. And then we plug it into the equation. So I would have y equals 2/3 x plus 7. That is some really boring stuff. I can't quite make it interesting. So let's make it slightly more interesting and at least disguise something in here. So let's write the equation of a line passing through the points 0, 5 and -3, 6. Slide that up a little bit. So we have a choice to make, right? We've got our different forms for the equation of a line. So I'm going to look at this thing and say, well, for any line, I need to know the slope. Was I given the slope? I'm going to go with I was given the slope in disguise. I was given enough information to find the slope. We can find the slope by thinking about what's going on the graph. You do not have to graph this. I am just like some visual aids myself. So I am gonna sketch a quick graph here. So if I think about those points, 0, 5, and -3, 6. So my line's gonna look something like that. And talked about this on Wednesday, but our slope is the change in y over the change in x. And I know some people say rise over run. Those words just don't connect with me. If they connect with you, awesome. So I think about my slope kind of moving from left to right. So if I have them graphed, I can think about, as I move from this point to this point, how much did my y value change? I went from 6 to 5, which is a change of -1. On my x values, I went from -3 to 0, which is a change of 3. For those of you that really prefer a formula, formulas work too. The way that I can get that change in y is by subtracting the two y values. So I'd end up with y2 minus y1 over x2 minus x1. And I'm using those subscripts as notation. And really kind of the secret thing that's happening there is that we declare one of our points to be like the first point. And it doesn't matter which one we pick. To be consistent with what I wrote over here, let's call this x1 comma y1 and x2 comma y2. So if we did this as a formula, it's going to look different, but be the same numerical value. So if I thought about this as a formula, then my y2 minus y1 would look like 6 minus 5. And my x2 minus x1 would look like -3 minus 0. If I simplify that, that's 1 over -3. We talked about this when we were talking about fractions and talking about negative numbers and stuff. -1 over 3 is equivalent to 1 over -3. And we can also write that with the negative out in front of a 1/3. All of those are equivalent. They're mathematically interchangeable. One of my just sad realities for you all, sad or empowering, depending on how you feel about it. Math has choice. There are always lots of correct choices, which can be frustrating when you're working through a problem, but that's our mathy reality here. Okay. We got the slope, but we still don't have the equation of the line. Again, we have choice. Now, we figured out the slope. I said that this was a great option if we know the y-intercept, and this is a great option if we know one point. Well, based on the information that I gave us, we actually have both. We have specifically the y-intercept because that x value is 0. And we have some random other point. So in the spirit of having choice, I'm going to do this two ways. I'm going to say, okay, since we know that the y-intercept is 0, 5, I can write down that our slope was -1/3, and my y-intercept here is 5. That's a choice. The other choice that we can make is to use our slope-intercept, our slope point form, and choose either of the points to write y minus 6 is equal to our slope times x minus -3. Or y minus 5 is equal to our slope times x minus 0. Any three of those is totally valid. You are completely done. You have written the equation of a line. I know this is the one that tends to feel more like the equation of a line, but they are all the equation of a line. Good times. I'm going to give you one more to try on your own. And this time, we're going to have the line that is passing through (1, -2, and (4, 5). You do not have to draw the picture. I'm just asking you to write the equation of a line. And you can pick which form for the equation of a line you want to use. Personally, I find this true about both writing and math. If you are feeling stuck, write something, anything you know, as a starting point. You might be surprised. Your brain might decide to do something with it. Not sure what else to do. Sketch the 2 points. Don't like what the formula looks like? Move on with your life. Write something else. How about a slope? Does anybody, you do not have to tell me what your answer is, but stick your hand if you think you have a slope. I've got some people who think they have a slope. Should we get the slope together? I'm gonna go with silence is a yes, sure. Let's get the slope together. I'm going to do it without a picture. I'm going to do it with the formula, but I'm also happy to draw a picture in a second. So I'm going to go with just, I think, sort of by convention, whichever point came first in the sentence, we call x1, x2, when we call the other one y1, y2. It doesn't really matter. But if I did it in that order, I would have 5 minus -2 divided by 4 minus 1. Now on the top, that 5 minus a negative 2, talked about this a little bit on Wednesday, but that I can rewrite as 5 plus 2. And then 4 minus 1 is going to give me a 3. So I've got 7/3. So that's my slope, is 7/3. Now I have a choice of which form of the equation to put it into. But I'm going to take the path of least resistance, meaning when I go up to look at my possible choices for equations, I will personally only choose our slope-intercept form if I know the y-intercept. If I have any other point, I'm going to choose the point slope form. So let's go back and take a look at this. Neither of these points have an x value of 0. Specifically, the y-intercept is the place where the x value is 0. Since we don't have that, I'm going to choose the second version of the equation and go for point slope. If we choose to use the first point, this would look like y minus negative 2 is equal to 7/3 times x minus 1. If we chose to use the second point, it would look like y minus 5 is equal to 7/3 times x minus 4. Either one is fine. You do not have to simplify anything. You could if you wanted to. Fractions are gross. Let's not. If I were going to do anything at all with that first one, I would probably choose to write that as y plus 2. There is honestly no good reason for that other than handwriting. If I were like typing this on a computer, I wouldn't worry about it. But if my handwriting gets a little bit messy or that page gets a little bit smeared and I lose the fact that that was minus a negative and it kind of just looks like one big minus sign, then I've written the wrong equation. So that's really why there's this mathematical convention that instead of leaving it as written as minus a negative, that we go ahead and switch that around to be plus something. How we doing? Questions about those? Question. See, that's why it matters with the negatives, right? This says y minus negative 2. Yeah, totally. But right, see, this is exactly the thing that minus a negative visually looks like too many other things. So that's why it's probably best that as soon as you've got a minus, that we switch that around to say y plus. Yeah. Yep. I like questions.
How come it's y minus negative 2 if we already have the isn't it y equals y1?
So the equation, so we got two different forms. This form is y minus the y value at one of the points. Okay. Yeah. Should we get a couple more examples? I think we got time for a couple more. So let's say this time I'm going to give us a picture just because I can. And that's -3 and that's 8. And there's my line. So we're going to find the equation of a line. I'm going to abbreviate equation of a line with an x-intercept of -3 and a y-intercept of 8. I could give this to you with a picture or without a picture, either way, right? So even if I didn't give you a picture, we could still work with it from this, find the equation of a line with an x-intercept of -3 and a y-intercept of 8. No matter what we're doing, I am looking for a slope as a starting point for my line. Well, if we're going to find a slope, our options are, do we have a picture where we explicitly told a slope, or do we have 2 points? In this case, I've given a picture. So for me, that's probably the easiest way to look at the slope. As I move from left to right, I went from a y value of 0 because we're on the x-axis to a y value of 8. So my change in y was +8. Our change in x, as I move from left to right, I went from an x value of -3 to an x value of 0 because everything on the y-axis has an x value of 0. So I moved over 3 to the right. So my slope is 8/3. Alternately, we could do this with an equation by turning those x and y intercepts into their ordered pair coordinates. So an x-intercept of -3 means the x value is -3, but by saying that it's the intercept, that means the y value is 0. That y-intercept of 8 means that the y value is 8, but because it's the intercept, the x value is 0. So if we did our slope equation, I could do this as y2 minus y1 over x2 minus x1. And then I've got that minus a negative thing again. So I am quickly going to rewrite that as 0 plus 3 and get 8/3. So either way, I know that my slope is going to be 8/3. If we have the y-intercept, I'm just going to use it. Since I have the y-intercept, I would write my final equation as 8/3 x plus 8. But it wouldn't be wrong to write that equation in point slope form using either of these points. So you could also say y minus 0 is equal to 8/3 of x minus -3. And then again, I got that minus a negative. I want to get that out of there. 8/3 x plus 3. Or using the other point, we'd have y minus 8 is equal to 8/3 of x minus 0. And I claim that all 3 of these equations are secretly the same, just with different things in disguise. And yep, if you want to use the point slope form, you just write it and walk away. This is the version of the equation of a line that we end up using more often in calculus, because most of the time in calculus, the information we're given is a point and a slope, or the information that we have to sort of deduce from the problem is a point and a slope. But we're very rarely talking about 2 points or y-intercepts. Stats, now we're talking y-intercepts. Clock in the room is slow. We've got 2 minutes left. Do we want one more example? Okay. Oh yeah, I got a good one. Because we haven't talked about this yet. So find the equation of a horizontal line passing through to -5. Okay. So we've got this form, we've got these two forms, secretly three, but the third one's garbage. Got these two forms for the equation of a line. And neither of them work particularly well for vertical or horizontal lines. They still work. We just have to get creative about them. So let's talk about what this means graphically. So here's my coordinate plane. That's my X, that's my Y. If I go to the point 2, -5, that's 2 to the right, but down 5. So I'm down here at 2, -5. When I draw in a horizontal line, here is my horizontal line. I've only given us one point, but we can get any other point on this line that we want to because we know it's horizontal. So that's the point 2, -5. If I came over here and told you that the X value was 10, what's the Y value? Totally. If I came over here and told you that the X value was -3, what's the Y value? Totally. So the equation of this line is just Y equals -5. Because it has no dependence on X. It doesn't matter what the X value is. Y is always -5. Now we can also get there by kind of going the track that we've had on the other problems, which is to find the slope. Since we now have 3 points, we can pick 2 of them and look at the slope. But my change in Y over change in X, the key here is that no matter which 2 points I move between, the change in Y is 0. Which means my slope is 0. So if I then went to think about a point slope form, I'd have something that looked like Y minus -5 is equal to 0 times X minus 2, or Y plus 5 is equal to 0, which means Y is equal to -5. So a couple things about a horizontal line. It always has this form Y equals a number, and the slope of a horizontal line is always 0. And I promise we'll have more fun with lines on Monday, but I am out of time for today. I'm gonna go ahead and stop my recording.